Alright, so today's video is going to be about how to graph and solve with exponential functions. You're going to have homework from Chapter 1, Section 5. 18 is the presentation problem due by the end of the week. And then here are your recommended practice that you're going to check in the back of your book by yourself. Make sure you've got everything ready to take notes, and let's get started. So let's first talk about defining what an exponential function looks like. So without any transformations, which you had the opportunity to potentially have reviewed earlier, that we will review later this video, anything that's exponential will be a function that is some constant times some base to the x power. So there might be, plus minuses added in with transformations, but this is your basic premise, where this first number is your initial condition. So whatever happens when x is equal to 0, and then a is your rate of change. And that rate of change is always based off of 100%. So if you see something has a rate of, let's say, 1.2, that is having an increase of 20%. Now, the graph of an exponential function, without any transformations, will always have three things that you can measure. It will always have a y-intercept of 1, so we'll have a point here. It will always have a horizontal asymptote on the y-axis. And it will have the next point here, so where x is equal to 1, where this point is equal to a as the rate of growth. And we've got a lovely function, and that's the exponential growth. There, of course, may be an exponential decay as well if a is less than 1. So that's what it'll look like. Now, let's solve some problems with that. Number 1, find the exponential function f of x equals c a to the x that passes through the points -1, 8, and 3, -2. So since our goal is to find this exponential function, that means we need to find the value for c, the initial condition, and we need to find the rate of change. And we're going to start by plugging in these points into our generic formula. So our y value is f of x. So this first one is 8 is equal to c a to the -1, because that's our x value. And our second one says that the y value 1/2 is equal to c a to the 3rd for our x value. So here we've got a system of equations, but it doesn't really look like what we normally would add and subtract. But what we can do is we can divide both sides by each other. As long as you're doing the same thing to both sides, that's fine. The nice thing here is that that simplifies out the c term. We end up with 8 divided by 1/2 is equal to a to the -1 over a to the 3rd, which we can simplify as 8 divided by 1/2 is 16, is equal to, bring this negative into the denominator, so a to the +1. We end up with 16 is equal to 1 over a to the 4th. Going to multiply this up, divide the 16 down. We end up with a to the 4th is equal to 1 over 16, which means that a is equal to 1/2. Because when you take the cube root, not the cube in this case, the 4th root, that cancels out. 4th root of anything of 1 is 1, and then of 16 is 1/2. So we've now found a. Obviously, don't erase things in the notes. I'm going to write it up here so that we remember it, and I'm going to erase this work here so that we can find c. So we found our a. We're here with our formulas that we had before, and now we can just, like with a regular system equation, select one. I'm going to go with this one because it's got the positive exponent, and plug in our a here to help us find c. So then 1/2 is equal to c times 1/2 to the third, which we can then say, well, that's 1/2 is equal to c times 1/8. Multiply each side by 8, and we end up with c is equal to 4. So then we have our goal met. We have a is 1/2, c is 4, and so then our answer, which I will once again do a little erasing to make some space for, our final answer is the function f of x is equal to c, 4, times a to the x, so 1/2 to the x. And that's our function. All right, so for number 2, we're going to do a quick review of transformations if you haven't already. When we add or subtract, this is a translation. And then when we have a negative put in, these are our reflections. When we have it added after the whole function is done, so in this case, a exponential function, but this refers whenever, the number is added afterwards. This is a vertical shift up and down. And then when the term is inside of the function right next to the x, it's going to be the horizontal shift left and right. And we use this negative to remind ourselves that it's going to go the opposite way we think. So if it says x plus a, it would go to the left, and x minus a is going to the right. With our reflections, if the negative is on the outside of the function, that means that we're going to flip our function over the x-axis, so up and down like that. And then if the negative is inside the function on the x, that means that you're going to reflect over the y-axis, back and forth. So these here we've shown specifically on an exponential function, but again, this is true of any function. So here we've got our exponential function, -3 to the x plus 2, and we see that we have a translation and a reflection. Here we have a negative in front, so that's a reflection over the x-axis. And then we have a plus 2 on the outside, which is a vertical shift up 2. So what I will generally start with is the base function here. So I'm going to do that in red just to help keep our colors separate. So remember, we're going to have our point at x equals 1 and our next one at the base, and we've got our asymptote. So this would be just the function 3 to the x. Next thing I'm going to want to do is I'm going to pick green for this next one, and I'm going to give the reflection, so -3 to the x. And all it's going to do is take those numbers, make them negative here. The asymptote's staying in the same place, and we get this. And lastly, our final answer, which would be to use that vertical shift, -3 to the x plus 2. So we're going to take these points that we have, scoot them up. We're also going to take that asymptote and scoot it up 2 spaces. Everything's moving. So we're going to end up there and up to here. And now we've got our asymptote and our final graph that passes through these 2 points here. Now, if you drew this in lightly and you want to now erase so that you just see that blue line, that's fine. And there we go as our graph of our exponential function and a little review of our transformations. If you have any questions, please leave them in the comments, or you can grab one of the tutoring slots in the calendar on Google Classroom. Talk to you later.